Let's look at the experiment that you did or may have done to find the difference between endothermic and exothermic processes. What happened and why in the two reactions. And please note that there was enough energy in the solution, in the water, to get both of the reactions to start. You had two reactions. In the first, citric acid reacted with sodium hydrogen carbonate. It produced a gas. Think about what gas that may have been. It produced a change in temperature. Look at your notes and see, did the temperature of the water go up or down? You then reacted magnesium with hydrochloric acid. It produced a gas. What gas was that? And it also produced a change in temperature. Did the temperature go up or did it go down? And that, of course, again, was the temperature of the water that you were working with. So how did it happen? Well, citric acid reacted with sodium hydrogen carbonate and formed carbon dioxide, which was allowed to escape. The temperature went down. What that means is the kinetic energy of the water surrounding the reaction was going to go down. The water molecules slowed down. That's why you saw a reduction in temperature. When you put the magnesium into the hydrochloric acid, hydrogen gas escaped, as it has in the several times you've done this reaction. The temperature of the surrounding water went up because the water molecules were speeding up. Their kinetic energy was increasing. So let's talk about energy of reactants and products. In the citric acid sodium hydrogen carbonate reaction, we know that the products had to have higher energy than the reactants because in the process of forming the reactants, like the carbon dioxide, they had to take in energy from their surroundings. That's why the kinetic energy of the water around them went down and the temperature went down. With the magnesium and hydrochloric acid, the products must have had lower energy than the reactants because in the process of formation, they gave up heat energy to the surrounding water molecules, which started moving faster because their kinetic energy went up. So we call the first kind of reaction endothermic. Our example, citric acid and sodium hydrogen carbonate. The water surrounding the reaction saw a temperature reduction. It went down. That means the energy of products is greater than the energy of reactants. The reaction requires energy to be added, or the reaction simply won't happen. You can see this diagram down here where the energy of reactants needed to be pumped into in order to produce the products. So the energy of products had to be higher than the energy of reactants. And this difference, this change in energy, came by slowing down the surrounding water molecules. The second kind of reaction is called exothermic, magnesium and hydrochloric acid. The temperature of the surrounding water increased. That meant that the energy of the products must be less than the energy of the reactants because the energy went out. The change was from higher to lower because the temperature of the water surrounding went up. Its energy went up as the reactant energy went down, becoming products. So let's think now, based on your experience, whether the following changes are endothermic or exothermic. I'll read them off. You can write them down. Make your hypothesis as to whether they're endothermic, that is, the product energy is higher than reactant, or exothermic, the product energy is lower than the reactant, and then you can check your answers after you turn the video back on. Sodium reacting with water, ice melting, water boiling, alcohol evaporating from your skin. You may have poured alcohol, rubbing alcohol on your skin at some point. Freezing water in your refrigerator. live steam condensing on a cold metal, hydrogen reacting with oxygen gas, or hydrogen peroxide decomposing with the help of a catalyst. So turn the video off, answer these questions, and then check your answers. And here are your answers. A couple of things. If you put alcohol on your skin, you probably feel it as cold. What's happening is the alcohol is evaporating, taking heat away from your skin, so the evaporation is an endothermic process. And in terms of freezing water in your fridge, while the refrigerator is running, put your hand behind the refrigerator and you will feel heat being blown out of the refrigerator. That's why we say freezing water is an exothermic process, just as melting the ice is endothermic.